They say space is silent. But silence, in the right conditions, becomes a signal. In the vast darkness beyond the stars, a faint whisper has emerged, one that might finally answer the question humanity has asked since the beginning: are we alone? From the earliest cave drawings to modern radio telescopes, our species has always looked upward. We mapped stars before we mapped the seas. We named constellations before we built cities. Something in us has always believed that what lies above holds the truth. And now the universe may be whispering back. Suspended in the void, orbiting beyond the moon's reach, is one of the greatest tools we've ever built, the James Webb Space Telescope. More than a camera. More than a machine. It's our eye into the origin of everything. What it just saw was K2-18b, a planet orbiting a faint red dwarf star in the Leo constellation. Located 120 light-years away, it was once just another blip in the data, until JWST pointed its golden mirrors toward it. What came back stunned the scientific world. This planet wasn't just interesting. It was impossible. K2-18b is a super-Earth, a type of exoplanet larger than our world but smaller than the ice giants like Neptune. These sub-Neptunes don't exist in our solar system. They are alien in every sense. Unfamiliar, unknown, and completely fascinating. It orbits close to its star. Just 18 cents, a distance that would be deadly in our solar system. But its star is a red dwarf, cooler, dimmer, more stable. Which means despite the proximity, K2-18b may fall into the habitable zone. That means one thing: liquid water could exist. And JWST confirmed the first clue: water vapor in the atmosphere. The presence of water in any form is more than encouraging, it's essential. Water is the universal solvent, the foundation of all life on Earth. To find it in the clouds of a distant world is like hearing your name shouted from across a canyon. You're not sure who said it, but you know it was meant for you. But that's not all they found. Alongside the water vapor, scientists discovered methane, a gas that shouldn't exist in large quantities unless something is replenishing it. Methane breaks down quickly when exposed to stellar radiation. If it's still there, it's being made by something. And then the real shock: dimethyl sulfide, DMS. On Earth, this molecule is only produced by life. Tiny marine plankton, drifting in the oceans, release DMS as part of their natural processes. We've never found it anywhere else in nature. Not from volcanoes, not from rocks, not from deep space. Only from biology. On Earth, DMS is a biosignature. On K2-18b, it might be the same. It's not proof. But it's a voice. A murmur. A question forming in the silence. Could this planet be alive? K2-18b's environment is extreme, at least by human standards. Its atmosphere is hydrogen-rich, which means it traps heat and maintains pressure in ways we're only beginning to understand. Its year lasts just 13 Earth days. Its skies may be endless clouds. Its oceans, if they exist, could be deeper than Everest is tall. We may be looking at a new class of worlds entirely. Astrophysicist Niku Madhusudhan coined the term Hycean worlds, planets covered in oceans and wrapped in hydrogen atmospheres. These worlds could host life not just in rare cases, but often. And here's the twist: Hycean worlds may be more common than Earth-like planets in the galaxy. Let that sink in. The conditions for life may be not just possible, but probable, across the universe. These worlds may have no land, no forests, no cities, just ocean. Deep, churning, hydrogen-rich oceans, shielded from space by dense skies. Life here wouldn't walk. It would float, drift, glow in the dark, communicate through chemistry, not sound. It wouldn't recognize us, and we may not recognize it. But that doesn't mean it's not there. JWST used a technique called transit spectroscopy to detect these atmospheric elements. As K2-18b passed in front of its star, light filtered through its atmosphere. That light was separated into a spectrum. Certain wavelengths vanished, absorbed by chemicals in the atmosphere. What remained told us what was there. It's like tasting soup and knowing every ingredient. Except the soup is 120 light-years away. But what does this mean for us, beyond science, beyond headlines? It means our definition of life must evolve. It's no longer limited to carbon-based, oxygen-breathing creatures walking on land. It could mean life forms that swim in methane seas, breathe hydrogen, and thrive in pressures that would crush a submarine. It could mean biology as art, so foreign, so elegant, that it redefines beauty itself. Imagine entire ecosystems beneath dense clouds. Photosynthesis, not from sunlight, but from radiation. Microbial colonies feeding off volcanic vents or chemical gradients, deep beneath an alien ocean. We've seen it before on Earth. Extremophiles they're called. Life that thrives where life shouldn't, boiling acid, freezing glaciers, radioactive waste. The building blocks of life are tougher than we imagined. K2-18b might not be Earth-like, but maybe it doesn't need to be. Maybe our standards have been too narrow all along. This isn't just a shift in astronomy. It's a shift in philosophy. For centuries, humans placed themselves at the center of the universe. Then we learned we orbit a star. Then we learned our star is one of billions. Now we're learning our biology might be just one version of many. We are not the default. We are not the prototype. We're one possible answer among countless questions. And perhaps, somewhere out there, another form of life is staring up at its sky, wondering if we exist. The tools we've built, JWST, future telescopes, deep space probes, they are not weapons or monuments. They are messages. Probes into the silence. Questions launched at light speed. What we found on K2-18b is not just scientific data. It is an invitation. An invitation to imagine more. To believe in possibility. To prepare for contact. Not with intelligent life, but with the idea that life itself is woven into the fabric of the cosmos. And yet there's caution. What if we misinterpret the data? What if DMS is formed through a rare geological process we've never seen before? What if methane is abiotic? What if we're wrong? That's the price of discovery. But here's the truth. Even if we're wrong, we're still further than we've ever been. Because every misstep teaches us. Every false positive sharpens our tools. Every mystery deepens our commitment. K2-18b may not hold the final answer, but it's forcing us to ask better questions. And those questions will shape everything. Education, policy, exploration, ethics. Do we own life beyond Earth? Do we protect it? Share it? Learn from it? What if we find a biosphere? What if we find a message? These questions used to live in science fiction. Now they live in science. And the ripple effect is already here. Private companies are designing telescopes to follow JWST's footsteps. NASA is preparing for even larger observatories. International coalitions are forming to study Hycean planets as a category. The search for life is now a budget line. And the people? They're watching. Young minds, kids with telescopes, coding tools, 3D printers, they're inspired. They're not waiting to be told. They're building. The future of planetary science may come not from a lab but from a garage. From someone who looks at K2-18b and whispers, what if? And what if we find not just one planet, but hundreds, thousands? Each one with its own story. Some just beginning. Some long-ended. Some thriving quietly beneath oceans of methane and dreams. The age of exoplanets is here. And it's no longer about rocks and gas. It's about life. Life as a cosmic force. Unbound by form. Unfazed by distance. Unlimited by time. And as we look at K2-18b, maybe we're not just looking outward. Maybe we're looking inward too. At ourselves. At what it means to be alive. To wonder. To hope. Because hope, like life, survives in the strangest places. Even 120 light-years away. And what we tasted was tantalizing. We still don't know what K2-18b's surface looks like. We can't see its waves or feel its wind or hear its thunder. We don't know if it has storms the size of continents or calm waters like glass. But we know something is there. And maybe, something is alive. The implications are staggering. If microbial life exists on K2-18b, it confirms that life is not unique. It is not a miracle. It is a feature of the universe. And if life exists there, it may exist on thousands of similar planets. Because red dwarf stars, like the one K2-18b orbits, make up nearly 75% of stars in our galaxy. If even a small percentage have planets like K2-18b, we are not alone. We are surrounded. That doesn't mean they're intelligent or aware of us, but it means the universe is alive in a way we've never imagined. It changes everything. Religion, philosophy, identity. Are we the center of creation? Or just one expression of it? Do we search for others? Or do we prepare to be found? And perhaps most haunting, what if they came long before us? What if K2-18b harbors ruins, not life? Fossils, not creatures? What if life thrived there, burned bright and then faded, leaving only chemical footprints in the clouds? JWST will continue observing. New missions will follow. Telescopes will grow larger. Algorithms sharper. The search won't stop. Because now we have a lead. And it's only just begun. Meanwhile, Earth watches. Children stare through backyard telescopes, wondering if someone on K2-18b is doing the same. Scientists double-check the data. Writers and poets revive ancient dreams. And the rest of us? We start to believe again. Because this isn't just about space. It's about hope. Hope that we're not alone in the universe. Hope that life is not rare. Hope that in the vastness of everything, we are part of something greater. And all of that, everything, started with a whisper. A flicker of light. A trace of water. A molecule. K2-18b may be the first world to tell us the truth we've been seeking for centuries. That the universe is not silent. And we were never alone.